So in the previous video, we have discussed how to find the resultant of a system of concurrent coplanar forces and how to resolve the forces, and based on the sum of the resolved components to arrive at the resultant forces. Going to illustrate it with the help of a numerical example. Consider a system of forces acting. Three forces are here. 300 Newton acting at 30 degrees with vertical, 200 Newton at 45 degrees with horizontal, and another 300 Newton at 30 degrees with horizontal. We are asked to find out the resultant of the force system. Find the resultant. So the first step is you resolve the three forces into x and y components. So let us start with the first one. The first force is 300 Newton. The first force is 300 Newton. It is inclined at 30 degrees with vertical. So I am going to make it as 30 degrees with vertical. So angle with horizontal is 60 degree. You resolve it. How will you resolve it? Away from O, outward. So the components are both outward. This is Fx. This is Fy. What about the value of Fx? This is 60, so it is 300 cos 60. 300 cos 60. So Fx 1 for the first force is 300 cos 60. And Fy for the first force, this is 300 sin 60. So this is equal to 300 sin 60. So we have resolved the first force into x and y components. Consider the second force. The second force is 200 Newton, 45 degrees with x direction. So to resolve this, first of all, direction, it is outward from O. So the two components should also be outward from O. Outward, outward. This is Fx. This is Fy. This is 200. This angle is 45 degree. So this component will be 200 cos 45. And this component will be 200 sin 45, or I can write for the second force the x component is 200 sin cos 45. So 200 cos 45 numerically. What about here? See, Fx1 is towards right, so it is positive. Fy1 is to up, so that is also positive. Here Fx is towards left, so it is minus. The force is acting, force component is towards left. Fy for the second, this component is also acting downward. So that is also minus 200 sin 45. I'll repeat once again. The force is 200 Newton away from O or outward from O. So this component outward. This component also outward from O. This is 200 cos 45, 200 sin 45. Since this is towards left, I have marked it as negative. Since downwards, it is marked as negative. Coming to the third force. Coming to the third one. 300 Newton. This is 300. Its angle is 30 degrees. This angle with horizontal is 30 degree. So this 300, this is towards O or inward. So this component towards O. This will also be towards O. These are the towards O or inward. So the Fx component will be towards O. Fy component will be towards O. This is 30 degree. So this component is 300 cos 30 Fx. This Fy is 300 sine 30. So the third one, Fx, third force component are 300 cos 30 is towards left. So minus 300 cos 30. This Fy component is up. So Fy component is 300 sine 30. Okay, the first step is over. We have resolved force 1, force 2 and force 3 into their respective x and y components. Okay, now I am going to sum up sigma fx. Take down the forces in x direction. Consider the forces in x direction. First one, 300 cos 60. Second one, minus 200 cos 45. Third one, minus 300 cos 30. So sigma fx is equal to 300 cos 60 minus 200 cos 45 minus 300 cos 30. So you will get it, add it together, you will get the value as minus 251.23 Newton. Similarly, we sum up the force components in the y direction. Sigma Fy. For the first one, it is 300 sine 60. Second, minus 200 sine 45. Third one, 300 sine 30. So add it together, 300 sine 60 minus 200 sine 45 plus 300 sine 30 will work out to 268.39 Newton. So step 1, resolve the forces in x and y component, and step 2, you find out, this is step 2, sum of all the horizontal components sigma fx, sum of all the vertical components sigma fy. Now I am going to mark these in figure. So I have got sigma fx, I will mark it the xy coordinate direction. Sigma fx is minus 251.23. That is in this direction. Minus 251.23 Newton. This is sigma fx. Minus 251.23. Sigma fy is 268.39 positive. That means it is 268 Fy is sigma Fy 268.39 positive. So sigma Fx is 251 negative, sigma Fy is 268 positive. So you complete this rectangle. So this diagonal will represent the resultant in magnitude and direction. Sigma fx negative, sigma fy positive. So R, the resultant R is equal to root of sigma fx square. Sigma fx square plus sigma fy square. So that is equal to root of 251.23 the whole square plus 268.39 the whole square will give you the value of the resultant as 367.63 Newton. Numerical value. Now regarding the sign or the direction, let it make an angle theta with this direction, with the horizontal Let R make an angle theta with x-axis. So that tan theta is equal to opposite side by adjacent side. This is Fy, this is Fx. So tan theta is equal to sigma Fy divided by sigma Fx. This is Fy 268.39 divided by Fx 251.23 will give you 1.068. Therefore, theta is equal to tan inverse of 1.068 will work out to 46.89 degree. So the resultant, this angle is 46.89 degrees. So this is in the second quadrant. Normally, we express the resultant, the angle which the resultant makes with, this is the positive direction of x-axis. So normal practice is to express this angle of resultant with x positive direction. So the angle of the resultant with the x positive direction, theta r, totally it is 180. So theta r is 180 minus theta, 180 minus 46.89 will work out to 133.11 degree with x positive direction. So when you give the answer, you have to give the resultant of the force system is 367.63 Newton, making an angle of 133.11 degrees with x positive direction. Okay, I'll give one more similar examples. So we'll pass on to the second example. A system of forces, concurrent forces are given in figure. Find the resultant. So, earlier example, I have considered force by force. I have resolved it. Resolve the components, then add it together. Sigma fx, sigma y, sigma fy, root of fx square plus fy square. Here I am not, since you are familiar with resolution and all that, I am not going to deeply into that, but simply write down sigma fx, sum of all the horizontal components. Consider the first one. Here itself I can mark. This is 25 Newton acting away from O, so its components will be outward. This will also be outward. If this is 70, this will be cos 25, cos 70, this will be 25, sin 70. I can easily mark there that force is acting outward from O, so both x and y components will be outward. The second force, consider there is one more force in this question. There is one more force. This is 20. That is horizontal, so need not resolve it in x and y direction. There is only one component along x-axis. Another for second force is 70. The 70 Newton. This is away from the joint, outward from the joint. So its components will be outward, outward. The angle which it makes with horizontal with this direction, say with this point, it is 50 plus 20, 70. The angle which it makes with horizontal, this direction is 50 plus 20, 70. So this is going to be cos 70, and this is going to be 70, sin 70. The third force, this 30 Newton, away from or outward. So its components are going to be outward. This is x component and this is y component. This angle is 20 degree. This is making an angle of 20 degree. So this is going to be 30 cos 20. This is 30 sin 20. Regarding this 40 outward, so x component outward, Y component also outward. The angle is 40 degree with horizontal. So the horizontal component is 40 cos 40. This is 40 sin 40. So all the resolved components, I wrote it as figure itself. Once you get practice, that will be enough. Now I can write sigma fx, all the horizontal forces take down. First one 20. Here towards right 25 cos 70. This 70 cos 70 towards left. So minus 70 cos 70. 30 cos 20 towards left. So minus 30 cos 20. 40 cos 40 towards left. So minus 40 cos 40. So I'll repeat once again. Sum of all the horizontal components 20 plus 25 cos 70 minus 70 cos 70 minus 30 cos 20 minus 40 cos 40. So that will work out to minus 54.22 Newton. Similarly, find out the sum of all the y components. For this 20, it is only purely horizontal, no vertical component. First one, 25 sin 70 up. 25 sin 70. Here, 70 sin 70, that is also up. 70 sin 70. 30 sin 20, that is also up. 40 sin 40 down. So minus 40 sin 40 gives 73.82 Newton. So we have sigma fx is minus. So sigma fx is 54.22. Sigma fx towards left negative. Fy is 73.82, so up positive. It is positive. Sigma Fy is 73.82. So complete it. Complete this rectangle. This diagonal will represent the resultant in magnitude and direction. R is equal to square root of sigma fx square 54.22 square plus fy square 73.82 square. So that will give 91.59 Newton. Now regarding the angle, so this is a theta, the resultant makes with fx direction. So tan theta is equal to sigma fy divided by sigma fx. So that is equal to 73.82 divided by 54.22, 1.361. Therefore, theta is equal to tan inverse 1.361, 53.7 degrees. So this angle, this theta, this is 53.7 degree. The angle which the resultant makes is x negative. This is negative direction. If you want it, get the angle with x positive direction. This is the angle theta r. The angle of the resultant with x positive direction, theta r equal to 180 minus 53.7. So it will be 126.3 with x positive direction. So this illustrates how to do it in a simple manner. Once you are familiar with the resolution, you need not write fx1, fx2, fy1 like that. We can, in the sketch itself, we can resolve it into x and y directions with the proper signs and add it together and make it simple. So thank you.